Hello, pre-calculus students. Today we are going to talk about section 5.1, which is angle and degree measure. Please make sure you have the supplies listed on the screen. So pencil, highlighters, if you like to kind of highlight things, I like to do that. So I use a lot of color. You would need to have your section 5.1 notes and then a scientific calculator. That could be an Inspire or it could just be any scientific calculator. Also Desmos, and I'll show myself using that, has a scientific calculator app or online. Okay, and then just make sure as you watch the video that you are doing the examples as you go. So pause the video, try the example, and then watch and see what I did. You're going to learn so much more by doing than just by watching. So please make sure that you are doing that. Okay, so first thing, and I'm going to do is I'm going to just show you, here's this Desmos scientific calculator. So if you just type Desmos, if you Google Desmos scientific, this is what will come up. And I'm going to use that, or like I said, you could use the Inspire if you have that. You could also use if you just have a scientific calculator. Okay, so here are the notes that we're going to be talking about. So this is section 1 from chapter 5. We're going to be talking about angles and degree measure. And the first thing I would like you to do is just read through that first paragraph. There's a word bank, and then just see if you can figure out. So pause and see if you can figure out where each of those vocabulary words fit into that paragraph. Okay, so let's go ahead and read through this. So an angle may be generated by rotating one of two rays that share a fixed endpoint known as the vertex. So this fixed endpoint right here, that is going to be our vertex. One of the rays is fixed to form the initial side. Okay, so the side that we kind of start with is called the initial side. And the second ray rotates to form the terminal side. Okay, so the side where you end is the terminal side. If the rotation is in a counterclockwise rotation direction, the angle formed is a positive angle. I know that seems kind of counterintuitive, right? To say that a positive angle is counterclockwise, but you think about the way we normally rotate an angle, right? We go this direction, which is counterclockwise, that gives us our positive angle. And if you go in a clockwise direction, so if you go the other way, then we're going to use a negative number to define that. So a negative angle. All right, so an angle with its vertex at the origin and its initial side along the positive x-axis is said to be in, we're going to call it standard position. So in fact, all of these angles here, the initial side is on the positive x-axis, so we would say that those are in standard position. See if I can focus this a little bit more. That's a little bit better. All right, and then we also know from back in geometry in middle school and so on, the most common unit used to measure angles is called the degree. And we're going to talk a little bit more about that right now. So right now I know that, we can measure our angles with a degree, but what if it's not an exact whole number? So in order to obtain a more accurate angle measure, Babylonians also broke their angles into minutes and seconds. So, if let's say they were trying to give directions, like a ship was sailing, and they wanted to say that the ship was sailing so many degrees, north of east. So if we thought of this as like on a compass, right? And we want to give the direction of the ship. Okay. So let's say it was like, let's say this is, 45.5 degrees or something like that. So let's say if this is 45 degrees, so what they would do is they would take that degree and they would break it up. they take 1 degree and they break it up into 60 increments, right? And so each of those increments they would call a minute. So if it was a little past 45 degrees, they would say 45 degrees. And if it was 45 and a half, they'd say 45 degrees, and they would say 30 minutes, right? Because they would take this 1 degree, let's say this is 45 and then this is 46 or something like that. They would take that and they would split it into 60 units so they could be more precise. Well, then they wanted to be even more precise than that. And they took each minute and subdivided it into 60 seconds. So kind of like our clocks are based off of that, right? So they took each degree and split it into 60 minutes. And then they took each minute and split it into 60 seconds. And that allowed them to be more precise because they had not defined decimals yet. So what we're going to practice next, and it says this right here too about the conversion. So a degree is subdivided into 60 equal parts known as minutes. Okay, so that's one conversion, right? We know that 1 degree equals 60 minutes. And we're going to use it almost looks like the foot symbol to denote minutes. All right, and then it says further, the minute is subdivided into 60 equal parts known as seconds. Okay, so then we know that 1 minute equals 60 seconds. So the first thing we want to do is we want to change these angle measures into degrees, minutes, seconds. So we know 15 in this first one in part A, we have 15 full degrees. Okay, so we have the 15 degrees. And what I want to do is I want to take this 0.735, so 735 1,000ths, and I want to convert that first into minutes. I want to find out how many minutes that is. So if this is 0.735 and it's degrees, I want to convert from degrees to minutes. So I'm going to use this conversion, right, between relating degrees and minutes. And I'm going to multiply, and you might have learned this, like if you're taking chemistry and you're converting between different units. So I want to end up with minutes, and I want the degree unit to cancel. So I know 1 degree is equal to 60 minutes. And see, when you're multiplying, it's like the degree unit cancels. So I'm basically multiplying 0.735 times 60, right? And that gives me 44.1 minutes. Okay, so I know I have 15 full degrees and I have 44 full minutes. Well, I know that there are 60 seconds in a minute. And so now what I'm going to do is I'm going to take this 0.1 and I'm going to convert that 0.1 minute into seconds, right? Because I know 1 minute equals 60 seconds. So then I'm going to multiply by, I want to end up with seconds. So I'm going to put the 60 seconds in the top and the 1 minute in the bottom, right? And then I'm going to multiply, right? And I end up with 6 seconds. So then I have 15 degrees, 44 minutes, 6 seconds. So that would be my conversion. Okay, and just so you know, if this were to have come out as a decimal, let's say it came out to be 6.7 seconds, then you just would have left this 6.7 seconds. Some people think, oh, I just keep multiplying by 60 until I don't have a decimal anymore. We just have minutes and seconds. So you don't just keep going forever multiplying by 60. All right, so go ahead and pause and try example B. You want to follow that same procedure. Okay, so for part B, I have 329 full degrees, and then I would take the 0.125 degrees and multiply by, I know that 60 minutes is 1 degree, and so then when I multiply that, I get 7.5 minutes. So I have a full 7 minutes, and then I'm going to take this 0.5, right, half of a minute, and then I'm going to figure out how many seconds. And some of you might be saying, oh, I already know, that conversion, right? Half a minute is however many seconds. And you could, because you really can think in terms of time, or you can just use the conversion, whatever makes the most sense for you. Okay, so then that is 30 seconds. Okay, so 329 degrees, 7 minutes, 30 seconds. We don't put commas or anything in between. We just leave it like that. Okay, so then example 2 is going the other direction. If I give it to you in degrees, minutes, and seconds, now what would it have been just in degrees? And it says to the nearest thousandth. Okay, and this is important. Thousandths means out 3 place values. All the directions are always going to say to the thousandth. And even if it doesn't, if you're converting between degrees, minutes, seconds, you always want to go to the nearest thousandth for accuracy. Okay, so there will be problems later on where you'll just be randomly given an angle in degrees, minutes, seconds, and it will be easier for you to put it into a decimal. And so you'll just always use that rounding to the nearest thousandth. Okay, so now we're going backwards. So I have my full degrees is 39, right? So I have 39 full degrees plus now I want to take that 5 minutes and I want to turn it into degrees. So I'm still using these conversions, but I'm really going the other direction, right? So I have 5 minutes times, right? So now I want to end up with degrees. So my 1 degree will go on top, the 60 minutes will go on the bottom. Plus, okay, now I want to take that 34 seconds and I want to go to degrees. So I don't have up here a conversion directly from seconds to degrees. So I can go from seconds to minutes and minutes to degrees, but I can't go directly from seconds to degrees. All right, we can come up with a conversion for that. And we can do that right now. But just like to start, we don't have that. Okay, and I'm going to put this kind of in parentheses for now, just so we can see they're separate. Okay, so this would be, first I would have to get this from seconds. So I know there's 60 seconds in 1 minute. And then I could go again. Right now I can convert my minutes. I know that there are 60 minutes in 1 degree. So the second unit cancels, the minute unit cancels, and then I'm left with just degrees. So really it's like 34 times 1/60th times 1/60th. So in general, to get from seconds to degrees, it's as though I'm multiplying by 1 3,600th. Okay, so I'm going to add that conversion up here, that 1 degree equals 3,600 seconds. And so in the future, I could just do that instead of having to think, okay, I have to convert twice. Now, to get your final answer, my recommendation is that you put this all into your calculator in one shot versus, figuring out what this is and figuring out what this is, and then adding everything up, because then you're like rounding, you're rounding, and you're rounding. So what I would suggest is that you add that all or put that onto your calculator at once. Now, if you have an Inspire, you go ahead and just use the Inspire. If you don't, then like I said, you can use the scientific calculator. So if I were using the Inspire, and let's hope I don't have a terrible glare. Can we see it? Okay, so there's the 39, and then plus, and you can do 5 times 1/60th, or you could just do 5 divided by 60, plus, and then what was it? 34 divided by 3,600. You can do it all in one shot. Now mine, if I hit enter, is probably just going to give me, oh no, it gave me the decimal. If it doesn't give you the decimal, just hit Control Enter. All right, so then I have 39 point, and remember I want to go to the nearest thousandth, so 0.092, but then I have to look at the number past the 2, which is a 7, which bumps the 2 to a 3. So then this is 39.093 degrees. Okay, so try part B. All right, so I would have 35 plus, I'm going to do the 12 minutes times that I know that 60 minutes is 1 degree, plus 34 times, and that was seconds, right? I know 3,600 seconds is 1 degree. And again, I would just put that all in my calculator all in one shot. So when you round, you should get 35.202 degrees. Okay, so we just kind of need that in the back of our mind because that's going to come up throughout the whole semester, really. Okay, so then just some other vocab here. All right, so if a terminal side of an angle is in standard position and it coincides with one of the axes, the angle is called a quadrantal angle, right? So like a 90-degree angle, because you've got standard position and the other side of the angle is on one of the axes, so 90 degrees. This is a negative 180, or it could be positive 180, or 270, or 360. That's just a special name for them. All right, full rotation is 360 degrees. More than 360 degrees is going to represent multiple rotations. Okay, so if I said 9.5 rotations clockwise, how many degrees is it? And I know 360 degrees is 1 rotation. I could just do 9.5 times 360 degrees. Okay, now remember, clockwise means my angle is positive, right? So a positive 360 degrees. Okay. Oh, you guys, it doesn't. It means it's negative. Oh my gosh. This is where I miss being in a classroom with people. Okay, negative negative 360. I'm glad I caught that. So negative 3,420 degrees. All right. Counterclockwise is a positive rotation. And again, we would just do 6.7 times 360 degrees. Multiply and get 2,430 degrees. And so sometimes you might be given something as rotations, but you really need it in degrees, and that's how you would get it there. All right. So next, we're going to talk about some special relationships with angles. The first one is coterminal. So the first thing I would like you to do is just pause the video, and I want you to look at, I've given you some different examples and non-examples for 4 different angle measures of coterminal angles. I want you to see if you can figure out what it means for angles to be coterminal. So here are examples of angles that are coterminal to 60. Here are some non-examples, and then so on for 135, 210, and negative 20. See if you can figure out what it means to be coterminal. So if you were stuck, it might help to sketch these angles and see what you notice. So if you were stuck, maybe try that. What you should be noticing is that coterminal angles always end at the same spot. And so what that means is that they share the same terminal side. And that is going to be our definition of coterminal angles. So they share a terminal side. Right? Like if you were to graph 420, so 420 would be, okay, 360, and then I have to go another, 60, okay, there's that. And then 780 would be 2 rotations, and then negative 300 would be going clockwise, right? And negative 60 would be going clockwise twice and then landing there. Okay, so they share the same terminal side. So then if we're like, how are we going to figure out coterminal angles? Well, what I would have to do is add or subtract multiple rotations. And so what I could do is add or subtract 360 degrees. So basically multiples of 360, right? If I just keep adding or subtracting those multiples of 360, I'm going to get there. So example 4 asks us to identify all angles that are coterminal with each angle and then find one positive and one negative angle that are coterminal with the angle. Let's actually start with that. So we want to do 3 things, right? We want one positive coterminal angle, one negative coterminal angle, and then all coterminal angles. And we want that with each of these. So you might want to pause and take a minute and see, okay, could I figure out how to do that, right? Okay, so one thing I could do is I could take the 86 degrees and I could add 360 degrees, and that would give me something positive, so 446 degrees. Okay. I could take the 86, the start, and I could subtract 360 and get negative 274. These aren't the only ones, right? Because I could keep adding multiples of 360. I could keep subtracting multiples of 360. So there are really infinitely many coterminal angles. So when it says, what are all possible coterminal angles? Well, we want a way to say 86 plus all the possible multiples of 360. And what we do is we say something like 360 times, we just are going to pick a variable. Usually in a math book, they would use a K or an N. And so it really doesn't matter. I don't even remember what our book does. It might do a K, it might do an N. It doesn't matter. Let's say we pick K. Now what we're going to do though is we're going to say K is an integer. Okay, and that's usually assumed when you do these things, that K is an integer. So that covers all the positive rotations, and then because it's an integer, also all the negative rotations. So smacking that 360K on there is what's going to get you all possible coterminal angles. Okay, so for the 294, same idea, right? I could take the 294, I could add the 360 and get 654. I could subtract the 360 and get negative 66. And then I could just add the 360K, and that gets me all of them. So it's always that same process. All right, so then this next one, if each angle is in standard position, determine a coterminal angle between 0 and 360. So here's where it's going to be important to read directions in the homework or on a test or something like that. It does say specifically here that your answer should be between 0 and 360. So please make sure that you're giving your answer in that interval. Okay, so 595, well, that's bigger than 360. So I'm going to take away 360 and I'm going to get 235. Oh, great. That falls between 0 and 360. That's where I needed it. And it says to state the quadrant in which the terminal side lies. Okay, so if I think about this, that would be 180. That's 270. So it falls somewhere in, this is quadrant 1, 2, 3, 4. So it's in quadrant 3. All right, so negative 777. Okay, that's too small. So I'm going to add 360 and see what I get. And I get negative 417. Okay, and then I add 360 again. And I see what I get. I get negative 57. Still too small. And I add 360 again. And I get 303. So, okay, if I'm thinking, okay, that's 90, 180, 270, 303 would be somewhere in quadrant 4. Okay. All right, now the last relationship that we're going to talk about is reference angles. So again, I have given you an example of a reference angle for each of these angles and then some non-examples. So again, go ahead and hit pause and see what you see. Again, draw. You might want to sketch the angle and the reference angle and see if you can notice some connections. Okay, so let's see what we see here. So for 60 degrees, so some of you might be noticing, well, there's only one reference angle, right? Like with coterminal, it could be infinitely many, but there's only ever one reference angle. Some things that people might be noticing is that they're always positive. You might be noticing that they're acute, right? They fall between 0 and 90. Okay, and those are all important things that we have to consider when we're naming reference angles. It has to do all of those things. All right, so 60 degrees. So here's the given angle is 60 degrees. So I'll do the angle they give me. I'm going to make the orange. So that's my 60 degrees. And then this one was 135 degrees. So I'm going to draw the angle that I'm trying to find the reference angle for in orange. Okay, 210 falls like down there. This is rotation. Negative 20, remember I would go clockwise. So this would be negative 20. So it's this rotation here. Okay, so now let's look at what the reference angles are. So here the reference angle is just 60. It's the same thing. Interesting. This is the same thing. Okay, this one, the reference angle is 45. So it's like here. This one, the reference angle is 30. So it's like here. And then this is the reference angle is 20. Okay, so I'm going to think, okay, what are some things that you maybe notice? And so in this one, they're the same. In this one, you might notice, oh, this is 45 and this is 45. Okay, and this one, this is 30 and this is 30. This is 20. This is a rotation of 20. Okay, the definition for a reference angle is the acute angle between the x-axis and the terminal side. So from between the x-axis and the terminal side. So in this case, it's the same. Here's the terminal side. Here's the x-axis. Here's the terminal side. Or I'm sorry, here's the terminal side. Here's the x-axis. Here's the terminal side. Here's the x-axis. Okay, without regard to any sort of like rotation. So it's always positive. So it's the acute angle between the x-axis and the terminal side. Okay, so go ahead and see if you can find that the reference angles for example 6. I strongly recommend that you sketch them to see that idea of where's the terminal side, where's the x-axis. It really helps. Okay, so for 120 degrees, so 120 degrees is like here, right? That's 120 degrees. Here's my terminal side, here's my x-axis. So I want to know what this angle is right here. Well, I know like this from here to here is 180 degrees, so I could just do 180, take away 120, and get 60 degrees. That's my reference angle. Okay, so I want to know what that angle is right there. Okay, the next one, negative 135. So negative 135 means I'm going to go clockwise 135. So positive 135 would have been like here. Negative 135 is that same rotation, but going clockwise. So like there. There's my negative 135. I want to know the angle between the terminal side and the x-axis. Okay, and remember it's an acute angle, so I would never pick like say, oh, it's 135. It's always the acute angle. So in this one, I couldn't have picked the 120. It has to be between 0 and 90. So I want to know what that angle is right there. Okay, so I could do 180 and then take away that 135 and get 45 degrees. Now somebody's out there right now saying, well, okay, I just always have to add or do something with a 180. It really is going to depend on where that angle falls. So just, it's not that cut and dry. I know it would be so much easier if it were, it just isn't. Okay, 312. So 312, somewhere over here-ish, right? Past the 270. So this is my reference angle here. So that was the original rotation, was this. I want to know what that is. Okay, well, I know all the way around once is 360, and that was 312. So I'm going to do 360 take away 312. So here we go as an example where it doesn't have anything to do with the 180. So that's 48 degrees. It will never have anything to do with like the 270 or the 90, which some people want it to do with, because it always relates back to the x-axis. So it's relating back to the 180 or the 360. It will never have anything to do with a 90 or a 270 unless you're like doing something and then doing something else, like doing two kind of operations to get there. All right, the last one, negative 195. So that would be negative 180. Negative 195 is going to go a little bit past. That's my negative 195. Okay, my reference angle is between this terminal side and the x-axis. Okay, so for this one, I'm thinking, all right, well, I went a rotation of 195. This was 180 and some change. So in my head, I'm kind of thinking it's like 195, take away 180. I went 15 more degrees. So that's my reference angle. Okay, this last example is just a little bit more practice if you want to try it. It gives you some information about, if the reference angle is this, the coterminal angle is that. I'm going to jot down answers if you would like to try those. You don't necessarily have to. We've done a lot of practice already. All right, everybody, be well. That takes care of our first section of Chapter 5.